Hello and welcome to Langford's Lessons. We're going to cover today how to calculate the rate of a chemical reaction. We'll cover mean rate and instantaneous rate. Before we start calculating the rate of a reaction, it's important that we understand all the different aspects of that chemical reaction. In this particular reaction, a student is investigating the rate of reaction between marble chips and hydrochloric acid. Marble chips, hydrochloric acid. Now, first of all, marble chips are made of a substance called calcium carbonate that has the formula CaCO3. Hydrochloric acid, of course, has the formula HCl. And these two react together to produce carbon dioxide gas, calcium chloride, which is a salt, and water. I can write a balanced symbol equation for this reaction. So the equation would look like this. Calcium carbonate, CaCO3, hydrochloric acid, produces carbon dioxide, which is a gas, water, which is a liquid, and of course the salt, which is going to be dissolved in the water. In this instance, the salt is going to be calcium chloride. Including my state symbols, and of course to balance the equation I simply have to put a 2 there. So this is the chemical reaction that's being investigated. The carbon dioxide gas will escape because it's a gas, and that's the reason why the flask will get lighter and lighter and weigh less. It'll have less mass, and if we observe that mass over a period of time, we can get an idea of the rate of reaction. In fact, we can even calculate how fast the reaction is happening. There are two types of rate calculations. You can calculate the mean rate of a reaction, which just gives you an average rate of reaction over, how long did the reaction take, how much gas is produced in what time. And you can also calculate an instantaneous rate of reaction. That means a rate of reaction at a particular instant, for example, at time 0, or maybe after 10 seconds. Or at the 20-second mark, what was the rate of reaction? That's called the instantaneous rate of reaction. I will be going through both. Okay, so let's see how we can calculate the mean rate of a reaction. The reaction we're going to be calculating the rate of is one between hydrochloric acid and calcium carbonate. It forms carbon dioxide gas, water, and calcium chloride. The carbon dioxide gas that's produced escapes from the flask and causes the mass of the flask to decrease. This graph shows the mass lost over time. We can use it to find the mean rate of reaction. To find the mean rate of a reaction, all you have to do is to work out the amount of mass lost and how much time it took. And you divide one by the other. So if we have a look at 100 seconds, over 100 seconds, this particular reaction lost 4 grams of carbon dioxide in that 100 seconds. So to find the mean rate, it's simply the mass divided by the time taken, the mass lost divided by the time taken. And that gives you 0.04. Your units are going to be in grams per second because your mass was in grams and your time was in seconds. This is just an average rate of reaction. Similar to if you wanted to find out your average speed if you went on a 5-kilometer run and it took you 1 hour. It would be 5 kilometers per hour. Of course, there would have been moments where you were going faster, and sometimes you'd have gotten tired and gotten slower. But overall, the mean rate, or your mean rate of your run, would be 5 kilometers per hour. It's the same in chemistry. It's the same for rates of reaction. When you're calculating the mean rate of a chemical reaction, all you want to know is what change was there in the products or reactants in terms of mass or volume, and how much time did it take. In this example, mass loss divided by time taken. In order to calculate the instantaneous rate of a reaction, what you need to do is to identify the point or the moment at which you want to calculate the rate, draw a tangent, and find the gradient of that tangent. So a summary of the steps would be: first step, draw tangent. At the point you want to calculate it. In this instance, it's 40 seconds. So over here at 40 seconds, I would have to draw a tangent. So I draw a line that just touches the curve and follows the path of the curve at 40 seconds. Okay, so be careful when you're drawing this. Try and make sure that it just touches the line and is following the same trajectory as your curve at 40 seconds. Once you've done that, the next step is to calculate the tangent's gradient. And your rate equals your gradient. So to find the tangent's gradient, what you do is you form yourself a nice little triangle that you're going to use in order to find the gradient. Gradient can be calculated by using the following. So gradient equals change in y divided by change in x. And so if you're finding the gradient of this tangent, which is a straight line, you find the change in y and you find the change in x, divide one by the other, and you've got your gradient. And if you have your gradient, you also have your rate, because they are the same thing. And so whenever I'm drawing a triangle to help me calculate my gradient, I choose easy points. So for example, between 3 and 2 over here, I know I have a change in y of 1 gram. And that makes my life a lot easier. And I then do the same thing, but I have to then use perhaps slightly more tricky points to find the change in x. This point over here is at 50, which is also quite an easy number to find. So that point there is 50, that's 50 seconds. This point over here, at the other end, is at 20. So 20 seconds, another easy number to use. And it's still going along that same line, so the points are quite valid. So my change going from 20 to 50 is 30 seconds. And all I then have to do is divide the 1 gram, the change in y, by the 30 seconds, which is your change in x. So to find my gradient, it's going to equal 1 gram divided by 30 seconds. And if I do that, that will give me 0.03 recurring, so 0.033 grams per second, and that is my rate of reaction. It was losing a massive 0.033 grams of carbon dioxide gas every second.